Okay, so now let's look at some polynomial inequalities. Now, we have to do these differently than we did the linear inequalities, but that's not surprising because we treated polynomial equations differently than linear equations. So we're going to do some of the same things that we did for polynomial equations, and then we're going to go basically a little further in order to solve the inequality. All right, so let's take a look first at the general approach. Now, it may not seem clear exactly what we're doing until we get in some problems, but let's take a look. So the first thing, again, we're going to move all the terms to the left-hand side of the inequality so that you're comparing to 0. All right, this is going to be the big thing about our solving of polynomial inequalities and then later rational inequalities as well. We want to compare to 0 because if you're talking about an inequality, then the easiest numbers to classify are negatives, 0, and positives. So it's clear when a number is less than 0, it's negative. It's clear when a number is greater than 0, it's positive. So it makes it easiest if we're always comparing to 0. All right, so once we have everything to the left-hand side, we're going to factor completely. We're going to locate the zeros of each factor and put them on a number line, breaking the number line into intervals. So far, when we locate the zeros, that's really the same thing as we were doing with equations. The zeros there would be the solutions to the equations, but we have a lot more to do here because it's an inequality. So that's why we're then going to put them on a number line and break up the number line into intervals. Then for each interval, we're going to use a test value to see whether that expression on the left-hand side is positive or negative. Now, we'll see that that test value, you're going to have a lot of freedom in choosing that because you can go anywhere in that interval. So finally, we're going to solve the inequality by choosing the correct intervals. We do have to watch and see if we're looking at the equal cases. So if we're talking about a less than or equal to or a greater than or equal to, and we will have to include the equal solutions as well. So let's walk through an example here. So our first example here is to solve x squared less than or equal to 5x minus 6. So just as I would with an equation, I'm going to get everything in this quadratic inequality to the left side. So let me take x squared, subtract 5x over, and add 6 over, and we get x squared minus 5x plus 6 is less than or equal to 0. So notice, this is the big deal here. I'm comparing to 0. Whoops, I misspelled comparing there. I'm comparing to 0. All right. So now I'm going to factor basically as if I were solving the equation version of this. And so that would amount to, so I have 6 there, so 2 and 3 multiply to be 6. I need a positive 6, so they'll have to be both the same sign, and they have to add to negative 5, so I would need negative 2 and negative 3. Okay, so I have x minus 2 times x minus 3 is less than or equal to 0. So the zeros here would come from each of these terms being 0. So x equals to 2 and x equals to 3. Those are the solutions to this thing equal to 0. Now, that's not the end of the story here, because we have to solve the inequality. So the easiest way to do this is actually going to be to make a number line. Now this number line is not our solution yet. This is a tool we're using to solve the inequality. All right, so I'm going to make sure to put 2 and 3 on my number line, and I'm going to break the whole number line at those two places. Okay, because I know that this left-hand side is 0 at those two places. Now, I want to have a few values in each of the intervals. So let's just say 1 over there. I'm going to have to probably use like 2.5 in there. And over here, let's just use 4. Okay, so the idea is that I am going to take these test values that I've put in each interval, and I'm going to evaluate them in this left-hand expression. Okay, so I'm going to plug them in. Now, I don't need to know exactly what I get when I plug it in. I just need to know whether the end result is positive or negative. So down here, I'm going to say that when I plug 1 into x minus 2, I get a negative. Now specifically I get -1, but I don't care about that. I just care that I get a negative. Now when I plug it into x minus 3, 1 minus 3 is negative as well. Now when I multiply these two negatives together, I get a positive number. So up here I'm going to denote that it's positive in that region. So basically what I'm saying is that any number you take from that region will give you a positive value. All right? And it doesn't matter what number from that region, because it can't give you 0 because we already found where all the zeros were. And it can't give you a negative because if it gave you a negative in that region, it would have changed from positive to negative, so somewhere there would have been a 0. So everything in that region gives you a positive value. So if I go in the middle here, 2.5, if I put that in, 2.5 minus 2 would be a positive value. 2.5 minus 3 would be a negative value. When I multiply those together, I get a negative. Finally, if I put 4 in, 4 minus 2 is a positive value, and 4 minus 3 is a positive value. Together, that's a positive. All right, so now I know what the left-hand side looks like as far as positive or negative in every interval. Now I'm just going to pick the ones that I want. So I go back here and I want less than or equal to 0. So when are numbers less than or equal to 0? Well, when they're negative or 0. So back on the number line, there's where my numbers are negative, and the 2 and the 3 are where I get zeros. I'm ready for my solution. So what I see is that, and I'll do the different notations here, that I get the answer I want if I'm anywhere from 2 to 3, including both 2 and 3. So if I'm 2 less than or equal to x less than or equal to 3. So there's the inequality notation version. In intervals, that would just be 2 to 3. And in a graph notation, that would simply be number line 1, 2, 3, 4. That would be 2 including 2, 3 including 3, everything in between, or if you like bracket to bracket. And there's my solution.